Okay, I think that's plenty of time for everyone to have joined. So, good morning, good afternoon to everyone, depending on where you are in the country. Welcome to webinar 3. This is titled Grid Integration and Asset Management, specifically blades. So we've got two themes here. One being the grid integration piece, and the second being asset management of blades. So we've grouped presentations into two. Tim, could you please move on to the next slide? Sorry, Jeremy. Thank you. So before we get going, we are recording this session. We do have a recording of the first day, the kickoff day, and if anyone would like to receive a copy of that, just reach out to either Marianne or I, and we can send across a copy. But the broad purpose of this research network is to share information about research in a Canadian context as it's related to wind energy. A couple of housekeeping things before we continue. So to all presenters, you have 5 minutes in total, and we will send you notifications at the 4-minute mark and at the 5-minute mark. To everyone attending, if you have questions, please hold off till the end. We will separate into breakout rooms, one for each of the topic. One for each topic, beg your pardon, and you can ask individual questions there. So moving on, please. So we've got 5 presenters for the grid integration topic. We've got Cornelius van Kooten from the University of Victoria, Brian Jansen from the Saskatchewan Research Council, Tim Weiss from the University of Alberta. I got myself from WeCan, and Tom Levy from NRCan. So next slide, please. We've got 4 presenters, 3, I'm sorry, from for the asset management topic. I won't read out their names in the interest of time, and I think we can get going. So if you could move on to the next slide, which I believe is the first one for grid integration. Yes, and the next one again. So our first presenter is Cornelius van Kooten from the University of Victoria. In case the floor is yours.
Okay, thank you very much. I've been looking at this issue of integrating wind and solar in particular, but more recently also biomass into existing grids. I've been looking primarily at this from a policy point of view. So even though my models look extremely complicated, they're actually quite simple from an engineering point of view, in the sense that I'm not worried about the details of transmission, let's say, whether or not we have enough transmission capacity. I'm not interested in the details of how particular kinds of assets operate. I'm interested in the overall operation of assets and how fast you can bring them onto or into production and that kind of thing, and in standby. So, but these kind of models give you a lot of perspective. So if we can have the next slide, I'll give you an idea of what kind of results that we're getting. And I should note, I have to leave before 2 o'clock because I have to teach a class at 2 o'clock. So I apologize for that. Right now, I'm in another session later and I don't have that constraint at that time. Can you move to the next slide? Yes, thank you very much. So what we've done is we've got a decade of data on wind and on solar. And this one, I think, gives you just the wind data. And what we have here is the potential hourly energy output for a 3.5 megawatt wind turbine in 3 Alberta regions. And you can see the red one there, where none of them go above 1.4 on an average. So that's in comparison to the 3.5. But you can see these very high lines over here on the right. This is Pincher Creek area in southwestern Alberta, where you can get capacity factors for an entire year of somewhere around 70%, which is almost unheard of. But if you go from Pincher Creek to Lethbridge, Alberta, for example, which is not even 100 kilometers, I think, and what happens is that wind just drops right down, and capacity factors, that'll be 0.7 up in the region of Pincher Creek will be down to 0.25 or that a little bit more, or even a little less in the Lethbridge area. But the blue lines and the black lines represent respectively the southeast, so towards Medicine Hat, and up in the north coming off the mountains as well. And what we looked at in this particular study, we looked at 4 cases, a base case that covers what's going on now, how much carbon is released within our model. We looked at what happens if you only go to renewable energy, and you can see it right there in that column. The total cost is prohibitive. All right, we're talking trillions of dollars. This is for the Alberta grid. And you'll notice that we would have to have somewhere around 15 million wind turbines and some 31 million solar panels. And that, of course, is an impossibility. So in other words, it is impossible for Alberta to go to a totally renewable grid without relying on energy coming from somewhere else. Then we looked at 2 scenarios where we decommission coal plants. One where it's 2/3 of the coal capacity comes from renewables, which is this one here. And the second one is where we decommission coal plants and replace 2/3 of the coal generation. Instead of capacity, we replace 2/3 of the generation. And you'll see that even at that, the cost tends to be quite high. And it turns out that basically it is very difficult for Alberta to reach its goals using wind and solar energy. What we do is we've got about 10 papers in this series now, and we've been looking quite a bit at nuclear energy. We've looked at hydro storage in British Columbia through a transmission link to British Columbia. And what we have found is that we can get down to about a 40 to 50%, no, not even 40% reduction in CO2 emissions in Alberta by relying on renewable energy of the sort that we're talking about here, wind, solar, and perhaps some biomass. But in order to get down to 90% or less, we would need nuclear energy. That's all there is to it, period. Thank you very much. And I will have to leave at just before 2 o'clock.
Okay, thanks, Case. Our next presenter is Ryan Jansen from the Saskatchewan Research Council. Ryan, the floor is yours.
Thank you, Eldridge. So yeah, my name is Ryan Jansen. I'm a senior research engineer with SRC. We've done a lot of work in the area of renewables and storage. And so this is one of our projects. We've had to pare this down quite a bit to get to 5 minutes, so hopefully I can make it. I've been threatened with the hook, so I'll do my best to stay within that. What we have is a smart grid test center, and it's in collaboration with Cowessess First Nation. We're actually located just outside Regina, Saskatchewan. And the site was originally commissioned in 2013. So there's an 800 kilowatt E53 Enercon wind turbine, along with a 400 kilowatt Saft lithium ion battery with 744 kilowatt hours of storage. In 2018, we added a 0.5 megawatt of solar at site. So then we could start looking at multiple forms of renewable generation with storage and how we can use that storage to improve the overall output of the system. So the original research goals were to evaluate renewables with storage. At the time, that hadn't been done at a utility scale level. And so that was one aspect, the main aspect we were looking at. We wanted to reliably do peak dispatch with our battery, make sure that we could operate consistently and predictably. And then smoothing was a large part of our system. And so we looked at smoothing the wind turbine by itself using energy storage. And then of course, now with solar and wind at site, we can have some innate natural smoothing between the two of them. I know this is a bit unique to Saskatchewan, but when it's nice and sunny and warm, we don't tend to have very much wind, but then solar is high. And alternatively, when it's cloudy and stormy, and especially in the changes of seasons, we have quite a bit of wind and little solar. Our capacity factor for solar is around 17%. And our capacity factor for wind at site is about 32%. So decent resources. And then of course, how we can use the battery to extend that smoothing was of interest. One of the more interesting ones I'll just touch on briefly here was extended firming, both manually and predictively. So we could look at, forecasts coming up and make a guesstimate as to where we thought the total output would be of the system. And then we could try to make a set point with our battery to maintain that level. But we took it a step further and did some predictive algorithms. So we scraped some publicly available weather data from Environment Canada's website, as well as Weather Underground, to predict the upcoming hour ahead generation for our site. Predominantly utilities will use that hour ahead, 2 hour ahead. I know that there's a progression to trying to get the resolution finer on that and do 15-minute ahead. So this would allow us to accurately and reliably basically buy in on an hour ahead basis and use the battery storage to maintain that bought ahead power level. So it was really quite interesting, and the graph there on the side shows it. And so on a typical day, our blue line was our wind plus our solar. The orange line was the total output to the system based on our predictive algorithm and the battery. And the battery charge and discharge is shown in green at the bottom, with the state of charge shown in gray. And you can see we went to a maximum state of charge of about 90. We dropped to about 40% at the lowest part. But overall, we were able to maintain that hour ahead capacity. So results after 8 years, we've been able to reduce volatility by up to 85% using the battery system. Our predictive firming was consistent hour ahead, provide consistent hour ahead power. It really is an interesting aspect of the system, and I think it will prove itself well going forward. And our battery, after 8 years of operation here, has still maintained excellent health. We've been careful with how we've used it, but our state of health right now is about 92%, and we estimate about 10 years of life remaining. So there's lots more that I would love to touch on, but maybe another time. And I'm sure many of you have seen aspects of this presentation in the past. So thank you very much. It's been a privilege to be part of this. Thanks.
Thanks, Ryan. Our next presenter is Tim Weiss, University of Alberta. Tim, the floor is yours.
Great. Thanks for inviting me. So I'll just quickly introduce the work on our next slide here of our small little team at the U of A. We're sort of a joint research group between myself and Dr. Andrew Leach, who works in the School of Business. I'm in mechanical engineering, and so we mostly have engineering students that are working on some of the market aspects of renewable energy in the Alberta market. As you probably know, the Alberta system is undergoing pretty major changes as it's phasing out its coal fleet in the next few years. It was originally a 2030 target and now likely to be complete by 2023. So pretty major change in the overall system, with lots of interest in renewables growing here right now. So we're interested in looking at what that means for the Alberta market and what that means for electricity prices. And some of the work we're looking at is listed here in terms of what it means for the as renewables grow, what it means for cycling of existing fleet, as well as you can see on the right hand side here. So as when the duck curve, the famous solar duck curve, arrives in Alberta, and what that might mean for market prices. We're also interested in, there's lots of talk about storage and hydrogen these days, especially as some of the coal plants are converting to natural gas turbines with hydrogen capability. And so that's the one kind of the next area that we're looking at with the work that I'm going to talk about today. So on my actual slide then is the next slide. The nub of the problems, I'm going to try to go around this slide in sort of clockwise order. So if we start in the top left-hand side of this particular graphic, what this is showing is that the black line shows us the average market price for all the generators in a typical sort of 24-hour timeline. And you can see when it's not windy, we get the red prices. And then when it is windy, we get the green prices. And this is the well-known merit order effect. As renewables come on, bidding zero into the Alberta market, it pushes prices down. And so we have this compounding problem that even though we all know wind is getting cheaper, the more that you put in the same location, the more it continually parasites its own prices. And so we've got a bit of a downward spiral for additional wind coming on. And equally important perhaps is how that ultimately punishes the economic viability of someone who's built in that area earlier, not expecting the next development. So what we've been interested in looking at is this idea of what other types of geographic dispersion might we be able to imagine in the Alberta system. So the bottom left-hand corner then is maybe not putting wind turbines. This is a hypothetical example of where we might imagine a different build out, but imagine wind turbines that are more geographically dispersed, and so they're not seeing exactly the same wind patterns. And so that's kind of the goal of the current work, to then theoretically be able to minimize the amount of storage that might be needed in the system. What we wanted to do this work based on publicly available data, and so we were using the Canadian Wind Energy, the Canadian Wind Atlas as our resource, and this is where we ran into a bit of problems. The one problem that we ran into, let me just back up. What we really wanted to do with the work then was to take the Wind Atlas data and correlate it to actual market data that we've seen, or compare it against market data to sort of make sure that we can validate that output. The one challenge we ran into, as you can see in the bottom right-hand corner, was the Wind Atlas data seems to be out of sync with Pincher Creek in particular, which is where we have most of our wind turbines. And so if you look at the bottom right-hand corner, you can see the simulated data in yellow, which is using the Wind Atlas, compared to the actual data in black. And so there was a real mismatch in that data, and we ended up having to parse that out and not use that data. However, other than that, the Wind Atlas seemed to match up reasonably well, and you can see the next two graphs, comparing the blue and the red lines. That's actual hourly performance data from existing wind farms compared to the Wind Atlas data, and so we were able to match that up reasonably well. And then the final graph in the middle, upper middle there, is looking at the diurnal patterns that we were able to match up reasonably good output. And so that's kind of where we're at right now. So now we know we can model, we've got relatively high confidence that we're able to model new wind farms using the Wind Atlas. And so we're going to be taking those different wind fleets, just geographic varieties, I guess I should say, and put them into our Aurora dispatch model for the market, and see how we might be able to optimize the wind fleet across Alberta, not only for market capture prices, but as well as for what that might mean for different storage fleets. So thanks for your time.
Thanks, Tim. I am the next presenter. Please move on to the next slide. Thanks. So I'm Eldridge Rebello, as I said at the top. I am Grid Integration Engineer with the Wind Energy Institute of Canada. And we are a non-profit research institute, and we own and operate our own 10 megawatt wind farm. And we've recently added a 100 kilowatt solar array, which has a mix of bifacial and monofacial panels. And we've also added a roughly 100 kilowatt, approximately 200 kilowatt hour battery storage system from Tesla. A lot of the work we do tends to be demonstration work, and we tend to focus on empirical data. To that end, I don't have a very complex slide here. It's just a high-level overview of some of the work we've done in the past. One of the things I like to emphasize is that we do have pretty significant data gathering ability. So we, in addition to our 5 wind turbines, the solar array, and the Tesla battery, we also have quite a few Met towers. So we have wind speeds, different heights. We have solar irradiance values, weather, general weather data. And so in addition to what our generators give us, we log almost anything that is made available. The bullets after this are just high-level overviews of some of the work we've done in the past. I won't go into the details of most of these because we do have published papers out. So if you'd like more information, just get back to me and I can send you links showing our work. One example is the first example I've got here is that we've used our own wind farm to demonstrate how wind generators can provide AGC, also known as secondary frequency regulation, at varying power levels. Another published work that we did was with our local utility, Maritime Electric, and we investigated how our battery storage system at the time could be used to displace diesel peaker plants. So this was diesel peaking generators on the island, and our aim was to use the battery storage system we had to offset the use of diesel. The one thing I will mention here is that the battery system we used in this work is no longer on site. So it unfortunately has been decommissioned. It was a GE system, and it was a molten salt battery. We've also worked with the Saskatchewan Research Council, and specifically the same site that Ryan has just went over in his slide. And we did a similar demonstration there of providing AGC with a wind turbine plus a battery storage system. That work is in press and it should be published in the next few weeks. We also work with Natural Resources Canada and their utility forum. And most recently, we've worked with Nova Scotia Power and Enercon to investigate something very similar, which is fast frequency response, otherwise commercially known as inertia emulation, and also droop control from wind farms. A bit about our future work. One of the things we have on the horizon is using near-term forecasts. I beg your pardon. One of the works we have on the horizon is using sky cameras to generate near-term forecasts for solar PV. This, of course, will use computer models and ideas like machine learning to generate forecasts based on cloud movement. So you can know a couple of minutes in advance what PV output is going to be. And finally, we'd also like to do work investigating, similar to what Ryan had on his slide, how hybrid power generators could work. So say sites that have solar, wind, and storage at the same site. So examples would include firming capacity or even providing frequency regulation. If you like more information, like I said, please get in touch either with Marianne or myself. And yeah, that's a high-level overview of the work we do. So moving along, our final presentation in this section is from Tom Levy from NRCan. So please could we move on to the next slide? There we go. Tom, the floor is yours.
Thanks, Eldridge. I'll assume you can hear me unless I hear otherwise. So I was hoping to have flashy slides like what Tim's able to put up, but with just one slide available, I think I'm not really in a position to. So I'm going to talk a little bit about Task 25, but I'm actually going to spend a bit more time talking about the work that we're doing in Canada and how it relates to Task 25. So for those of you who aren't aware, IEA Task 25, International Energy Agency, operates a collaborative forum for undertaking research and whatnot. The link was on that previous slide. Established in 2006. You can read about. No, you can go to the next slide. That's fine. Thank you. I'll let you read about what they do. Really, it's, if you look at the bottom 4 bullets, they're developing insight and knowledge papers as well as recommendations in a number of different areas. So they do have a long history of publishing fact sheets, white papers, guidance materials. In fact, the Pan-Canadian Wind Integration Study that was led by the Canadian Wind Energy Association followed the recommended methodology that IEA Task 25 put out. I'll also say that from my perspective of the task, there's a clear evolution of their activities. The most obvious, of course, is the addition of solar, as historically this was entirely a wind-focused task. They're increasingly looking at market evolution opportunities, and I think that based on my perspective from what I can see, I really don't see technology as a limiting factor here. I think actually more regulatory and market is where we're having hiccups, and I'll touch on that in a little bit. They're certainly looking at more focused attention on the latest mechanisms to enable and incentivize participation of non-synchronous generation in reliability markets. As you saw from Tim's slide, depreciating energy prices by just providing energy into the system is not necessarily going to work in the long run. In fact, I'd argue it's not working right now. So we need to figure new things out. And I know the new Canadian Renewable Energy Association is very focused on that, as well as a number of other groups out there. So Canadian contribution towards Task 25, I'll highlight a few things that we're leading or following in Canada relevant to the Task 25 work. Eldridge touched on the PERD work that we sponsored for WECAN to either execute at their wind farm or work with. In fact, CowSS was one of them. We're very happy about that work, and that has been published in Task 25 material. The utility forum activities, which we don't really have time to go into too much detail, are certainly there. And that, of course, is the AGC FFR PFR work that we're doing. At NUTB, there's some future work around grid code, and I know Eldridge is working hard on Task 3 work that will be hopefully coming out this year, if not next. The North American Renewable Integration Study, the largest grid integration study of its kind, getting down to 5-minute dispatch intervals and looking at a series of carbon-constrained futures, is due to be published actually in the next several weeks, hopefully. So please stay tuned for that. And I'd like to highlight a few things in Nova Scotia. I think it's often perhaps a forgotten place, but I'd say that actually, if you look at what Nova Scotia is doing, they're ahead of a lot of provinces in many regards. They were the first to put their hand up around the utility forum to do work out at the NUTB wind farm. Power advisory was retained by the Nova Scotia Department of Energy to look at the PPA considerations with regards to non-synchronous generators providing essential reliability services. And right now, Nova Scotia is going to be drafting, as part of a collaborative innovation process around the recently announced Green Choice program, revisions to that PPA. And the PPA is currently being drafted by the utility and SPI, and further engagement with key stakeholders to finalize that is coming up. OERD, my employer, the Office of Energy Research and Development, is leading the Innovation and Electricity Regulation Initiative, IERE. Really, that is looking at dialogues around regulatory reform, and I think clearly an area that needs to be looked at. And I know a number of utilities and their regulators are involved. And lastly, I'll leave it at this: with the proposed Natural Resources Canada-led Smart Renewables and Electrification Pathways program, SREPS, it's a proposed $1 billion fund to provide capital support to enable wind demand response storage to develop projects that will allow them to provide support and provide essential reliability services when they're called upon. So I'll leave it at that, and thank you for your attention and the opportunity to present today.
Thanks, Tom. So that concludes the first batch of presentations, which were all about grid integration. So moving right along to the next set of 4, which is asset management, specifically blades. So we've got our first presenter here, Najiba. The floor is yours.
Yeah, thank you. Thanks for giving me the floor. This is Najiba Akhtar. I am from School of Engineering, UBC Okanagan. I will try to be as informative as possible with my current master's research. Just a couple of things that I would like to share with you today are the motivation of this research, objectives, methodology, and the present activities. We are all here for a common purpose, and that's for utilizing our wind energy efficiently. Literature study reveals that the climate have caused the leading edge erosion to develop into a serious industry concern. The previous researches has highlighted the leading edge droop as a better solution to this problem. And the motivation of this work is from the attained aerodynamic performance enhancement from previous 2D simulation at an intermediate Reynolds number. And the main target of this work is to see the transition phase, which is delayed while using droops. And the focus of this work is to verify the physical basis and to identify the important flow characteristics in this phase with the blade elementary momentum method and three-dimensional LES simulation. As we all know, large simulation can predict the transition well accurately. And as per our methods, we are up to high fidelity 3D simulation using a C-type mesh of approximately 30 to 40 millions of cells. And for speeding up that simulation, we will be using the initial two-dimensional simulation results. Those numerical results will be compared to available experimental and X-foil analysis of the flow characteristics at that delayed transition phase. And the existing blades used in sub-megawatt wind turbine will be modified using that drooped airfoils, and the power and the annual energy production of that wind turbine will be analyzed using blade elementary momentum approach in QBlade software, which will ultimately compares the rotor aerodynamic performance with and without leading edge droop with accuracy and precision. And currently, we have chosen an airfoil. We have modified that airfoil with a selected droop configuration, and three-dimensional large ED simulation is running with OpenFOAM, and it's basically for verifying the case setup resolution and fidelity for further research activities ahead. This is, in short, the overview of my research activity. Thank you. That's all.
Thanks, Najeeba. Moving along, our next presentation is from Patrick from the University of Quebec. Patrick, the floor is yours. I'm not sure if I was muted there, so I'll just repeat myself. Our next presentation is from Patrick at the University of Quebec. Patrick, the floor is yours.
Thank you, Eldridge. Hello, everyone. I'm Patrick, a PhD student at UCAR working on flow diagnosis on wind turbine blade via spectral imaging. Spectral imaging technique combine modern imaging and spectroscopy to obtain both spectral and spatial information from an object simultaneously. Spectral imaging aim to acquire the spectrum for each pixel in a scene image in order to locate object, recognize material, detect mechanism. Please, next slide. This experiment is intended to apply the hyperspectral imaging in the fall detection on wind turbine blade like crack, erosion, and ice accretion. For this purpose, a hyperspectral sensor with a spectral resolution of 3 nanometer and a bandwidth ranging from 340 to 1700 nanometer is used to scan a blade sample of 44 centimeter in length and 29 centimeter in width and a thickness of 4 centimeter, with defect size ranging from unseen to severe with different thicknesses of ice. Next slide. This graph presents the reflectance of normal blade signature in blue and defective blade signature in red versus the wavelengths in nanometer. This graph proves that the crack reflectance value are lower than those of the normal blade signature for the wavelengths ranged between 300 and 600 nanometer and 1000 to 1700 nanometer. Whereas between these two ranges, the crack signature achieve higher values of reflectance than the normal blade signature. For the ice signature, there is a total absorption around 1450 nanometer, where the reflectance reach 0. Please, next slide. After scanning the blade sample, the 3D image of the wind turbine blade specimen consisting of 542 band in wavelengths and 2 spatial dimension of 44 pixel in length and 29 pixel in width are present. This data cube is fed into a detection algorithm, and the result is summarized in this table. Where 100% of detection probability is present for the crack, erosion, and icing. Please, next slide. To the illustration presents the abundance factor of the fault where the region free of fault are colored in the dark blue. Light fault location are indicated in light blue, and the severe fault are spotted by yellow spots, as you can see in this figure. Please, next slide. In order to reduce the amount of data computed, we have reduced this data cube from 542 band into 555 band by means 90% reduction, while maintaining a 100% detection probability with a zero false alarm rate for the crack, erosion, and ice. Thank you so much.
Thanks, Patrick. Our last two presentations here are from Carrie Houston, who's also with the Wind Energy Institute. Carrie, the floor is yours.
Thank you. So like Eldridge said, I'm Carrie Houston, Manager of Operations and Engineering here at the Wind Energy Institute. First, I'm going to speak a little bit about the IEA Task 46 wind turbine blade erosion efforts. That's just a new IEA task. It's just been created. This started about a year ago. And basically, there was a leading edge erosion symposium that went on at the Danish Technical University last February. It was 3 days of research all about leading edge erosion, 3 full days. And it was amazing to see how many different groups were concerned about this and how big of an issue this still is in the industry. So following those 3 days, there was a technical experts meeting to discuss, okay, there's obviously a need to create an IEA task on this and pursue a bit of an organized version of this type of research. So the group got together, 29 participants, and kind of laid out the groundwork for how this research was going to work. So basically the consensus was this is still an unsolved issue. Repairing leading edges is costly. The downtime to do it is costly. The materials are costly. And with offshore installations becoming, more and more common and just continually ramping up, larger rotors, higher tip speeds, this issue isn't going to be going away. So the group got together and since February last year, worked over the course of the year to put together a very good IEA task scope with 5 work packages within it. The participants right now are from, I think we have 9 different countries here. We've got Belgium, Canada, Denmark, Finland, Germany, Netherlands, Norway, Spain, United States. And some of the stakeholders involved in the research are NG, ourselves, DTU, Hempel, Ørsted, VTT, Freiherr, Covresto, Nordex, TU Delft, Suzlon, TNO, just a wide variety of different contributors, Cornell, Sandia from the US. So what I thought I'd do is just kind of do a quick rundown of what this overarching task is going to entail. So basically it's broken into 4 work packages. One's 5 actually, but one's just a management work package. And this will be delivered over the course of 4 years, starting this month, March 2021. And so basically the first work package is studying climate conditions. So wind turbines are deployed in a variety of different climate zones. So what are the conditions that are causing this leading edge erosion? And how can it be sort of identified what the crucial meteorological parameters are contributing to leading edge erosion? So this package is going to look at that, look at what is out there for meteorological data, what's out there for sites that can give some history and actual results for what they're seeing in their conditions. And then can it be put into like a recommended practice for how to take those meteorological measurements, what data is good and what data is bad, but then also to try and get it into some kind of leading edge erosion atlas, roadmap, or something where if you're going to develop a wind farm, you could reference it and say, okay, there's meteorological data in this area, and we know that it's going to be, this is going to be a higher erosion area, or we should maybe look at this other option. So that's what the first work package is looking at. And the work package 3 is looking at wind turbine operation with erosion. So how does erosion impact your annual AEP? What's the loss of production that you're experiencing with various classes of erosion? So you can kind of look at a payback there, and also looking into standardizing damage reports for inspections of leading edge erosion and how you're going to classify them, and you see a wide variety all over the board of just random drone pictures in a file folder, which we have, and then also structured reports of, okay, this was inspected, there's measurements here, this is how far the erosion has gone, that sort of thing. So that third work package will look at that, and also look at, is there a potential for erosion safe operating mode? So we know from sensors on our site that the conditions for a significant amount of erosion are coming up this weekend. Should we change the way we're going to operate our wind farm to save the asset a little bit? And then looking also at different performance loss models as it relates to erosion. And then there's a whole work package about laboratory testing that's going to happen. So they'll take different leading edge protection products, coatings, tapes, shells, and then run them through different laboratory testing, erosion machines, that sort of thing, looking at different tip speeds and how all different types of conditions can affect the formation of erosion. And then the fifth work package is kind of bringing all of that together. So, how to properly assess damage models, understanding what the damage mechanisms are, proposing individual modeling approaches for different LEP technologies, that sort of thing. So in the end, there's a lot of work broken out into quite a few different groups, and looking to produce things like literature surveys, topical reports, recommended best practices, and some standardized models for the industry to use. I'll throw it back to you, Eldridge.
Thanks, Carrie. So you do have one more presentation, right?
Yep.
Okay. I think you can carry on then.
Okay, perfect. So I'm up again to talk about specifically what we're doing here at the Wind Energy Institute with our own wind park, looking into leading edge blade erosion. So basically, for those who don't know, we have a 10 megawatt wind R&D park, so 5 turbines, 2 megawatts each. And these turbines were commissioned in 2013. And by the summer of 2014, we saw that we were starting to get leading edge erosion occurring, paint failure, erosion, pitting, things like that, by looking, with long lens cameras, that sort of thing, for different inspections within the first year. So we started with our OEM asking for remedies, asking for repair work to begin. And so the first year, some repair work began. It was basically just repainting. And it just should be noted that we didn't have any specific leading edge protection products on the turbines to begin with. So it was basically paint that was, technically rated for our area. But we are, as you can see in the picture here, we're right on the coast. So we're in a pretty intense climate. So within the next year, we had to have repair work completed again. We were seeing even more erosion. And so eventually we were having some internal blade work done on our rotors by our OEM, warranty work. And the blades were on, the turbines were being, the rotors were being brought to the ground. And so we just decided, okay, this is our opportunity to apply some proper leading edge protection to sort of avoid this, you know, every year trying to repaint, repair. So we did install, we decided to turn it into a field study, 4 different leading edge protection products, different materials, 2 different versions of leading edge protection tape, and 2 different paint products to the 4 turbines that you see there along the coast. And then we applied one of those products as well to that 5th turbine there. So we had 4 different protection products on those turbines there, you see 1 to 4. And then we follow that up with physical inspections of the blades using cameras and drones, and working with one of the local universities here for some of those drone inspections. And we also started a little more in-depthly collecting site characteristics, so monitoring our precipitation and our ice. And there's a photo there on the bottom of our Campbell Scientific Weather Station, which measures precipitation droplet size and things like that. There's a picture there you can see of a big chunk of ice that came off of one of our blades that was laying close to one of our trucks in the substation after an icing event. And then you can kind of see a photo there of one of our blades just with some erosion prior to repairing. So these are just some of the things, like we do see increased freezing rain events, it seems, lately, as it seems where climate change is bringing more freezing rain than basic snowstorms for us, which we would think is going to contribute to this. And this is one of the things we're going to be tracking and researching. So we've started keeping a really close eye on the characteristics of the site. Within, we installed the leading edge protection field study. We installed those products in the summer of 2016. And within 3 years, we found that we had to do almost like a full replacement of the leading edge products. So even with leading edge protection, we are on a 3-year repair cycle, and it's not cheap, and it's a fair amount of downtime. So we're looking at this quite a bit closer. What other products are out there? What are our site conditions that are causing, like what are the main site conditions? When is the most erosion happening? That sort of thing. And basically just increasing our focus on what's happening. We're starting to do a little bit of performance investigation as well with some of the SCADA data that we have on site here. What was the performance like before the leading edge protection was put on, after, and then as we get closer to, you know, that 3-year cycle where we need repair again and that sort of thing. So yeah, so far we are doing a little bit of collaboration with some of that SCADA data with a PhD student at Texas A&M University and with NREL, a little bit of a research collaboration there. And then we're also participating, like I said earlier, in the IEA Task 46. So we'll be able to provide some of our experience with this in that task as well, some of our inspection reports, our history, our SCADA data, to sort of give a bit of a field, a real life field validation to some of the modeling that goes on there. Yeah, and I think that's a good summary of what we see to date. I can't get into which products for which. Those are a little bit confidential, but safe to say, no matter the product, we are on a 3-year repair cycle at our site.
Thanks, Gary. So that concludes our presentations for this session. So moving along to the discussion phase, this is where, if you've been listening and you have questions, you can directly ask the presenters or move to a broader discussion. So that said, we will break into two groups. one being the grid integration group and the other being the asset management group. So we will have 2 breakout rooms here in Zoom. And by this point, I'm pretty sure that most of you have had some experience with these breakout rooms in Zoom or in some form or the other. But you will be given an option to join either group. It should show up on your screen. Remember, you can always switch between groups, and you're free to join either one. So you should see the option for joining a group coming up on your screen right now. The one thing I will say is that the grid integration group will be moderated by me, and the asset management one will be led by Carrie. So I will leave it at that, and I will see you in the grid integration breakout room. It's good to see this is working well. I think we just give it another couple of seconds just for anyone else to join, and we can kick things off.
That's a nice background, Eldridge.
It is.
Yeah.
I stole it off Marianne. Quite happy with it.
Absolutely. Better than Tim's background. Pretty drab. Mine may be the worst of them all.
Pretty sterile out the university here.
Yeah.
Although I do have a
Oh, there
turbine. There you go. Whoops.
So you're at the university, Tim?
Yeah, I'm allowed on campus, but not many of us are. So it's kind of a post-apocalyptic feel here.
I don't know if it's post-apocalyptic yet. Are we post that, or are we still in the thick?
Yeah, definitely the way it feels walking around. It's like The Walking Dead.
Yeah.
Okay, I think that's enough time for everyone who wants to join to have joined. So just as a quick reminder here, this session is still being recorded. We will distribute the recordings towards the end of the entire session. Probably next week or the week after, you should hear back from us about the recordings. Coming to the topic of this breakout room, this is about grid integration. I do have a couple of discussion points here up on this slide. Before I give the floor over to all of you, I will do my little spiel about why we think data is important. One of the questions that keeps getting asked is, in different contexts, is what barriers are there to integrating more wind, solar, even onto the electric grid? And there are a couple of ways you can approach the question, but the one we'd be interested in here is from the perspective of research, what else can be done? And one of sort of avenues we can see here is allowing wind to do more than it already does. The reason I mentioned data right at the top is you'll see most wind turbine manufacturers claiming many things. Often this is similar to what the automotive industry does, and there aren't really standardized methods for verifying those claims. So a lot of the work we do tends to revolve around gathering data, analyzing data, and making that data public. So that's the most important part of the chain there, putting it out for criticism and critical analysis by anyone else. So that's my little spiel on making data public and more accessible. Anyone with thoughts about that? Possibly you have data to offer. Possibly you'd like our data. Floor's open.
I can start, Eldridge. I think, the notion of data, I think everybody is aware there just isn't really any in Canada. And that kind of is where we came from towards Utility Forum. And I I tell this story. I was in Denver and I was sat with a fellow by the name of Steve Boyning, who was a reasonably senior fellow in Excel Energy. And I was telling him about the PERD work that we were doing with you guys to follow AGC signals and see how well. And I was quite excited at some of the preliminary results. And Steve says to me, he says, "Oh yeah, we got 30% of our fleet on AGC." And I said, "Oh wow, that's amazing. Where's the data?" He goes, "Oh no, I can't share any of that data with you, but they work great. Just trust me." I mean, he wasn't so dismissive. He understood that it would have been good, and that's where we came from with regards to the utility forum is trying to make sure that whatever we do is as public as possible. But I don't think it'll provide the rich data sets that you're thinking about here. And I think that's really the rub is where are those rich data sets coming from and what can they be used for? And I think that there's a lot of different perspectives about what the data will tell us and how you can slice and dice it. And as I mentioned in my talk, that I think one of the biggest barriers are the markets, are the regulatory systems, and that those markets have a challenge evolving because there is a lack of data. The utilities don't necessarily understand in some cases what they can do with the data or what that data might look like and how that data might help us better value ancillary services as kind of just a baseline measure. What's the value of inertia? And I don't think, system operators will say it's the glue that holds the system together, but they don't pay for it. So now if I take it away, what's it worth to you? So I think that's a continual struggle with trying to value this, and some of the data that you're collecting and hope to be collecting, I think may help answer that. So I'll leave it at that.
And I want to add something about the data. I have some, it is right. I'm a PhD student at University of Victoria. Before starting my PhD, I used to work at Siemens Gamesa Renewables as a load engineer. And I used to work on measurement and data measurement and data collected by the wind turbines to see if what we're doing or what we are doing in terms of load calculation and also the power production matches what we see on the field. And what was interesting was the data ownership. So what you're talking about, that we don't have access to data, it is not only that we don't, as academia, don't have access to data, but also sometimes in industry, you see the utility operator companies, they do not share the data because they are the actual owner of the data and they are the one that they decide what to do with them. And interestingly, they don't do that much, but at the same time, they don't also let others touch it, which I found it quite staggering. Like, okay, you are sitting on the gold mine and you're not taking it out. Why? Yeah, it is something that I don't know how we can do that. It is something that was a struggle there in industry sometimes, and it seems it's a struggle in academia also.
I'll say a word too about that biggest barrier. Like I look at that question and there's a few barriers that I can see. I think the one that sums it up would be the holistic approach to integrating wind. I think that somewhat lacks, at least in the Saskatchewan context, and I assume it's the same for other utilities, but that holistic approach when you're integrating wind and looking at spatial diversity. For instance, for Saskatchewan, they'll issue an RFP for usually 100 megawatt to 200 megawatt capacities of wind farms. And it's all competitive based. And so it drives people to go where their capacity factor is going to be the highest. But that doesn't necessarily help the whole case for the province. There's a lot to be said for geospatial diversity. There's a lot to be said for other programs, like you said, for making use of the other value streams that a wind turbine can offer. And yet that isn't being valued in these utility programs, at least again, in Saskatchewan's context. They're paying for energy. That's kind of where the buck kind of stops on that. And so I see that really as a barrier to getting high penetrations of wind energy is when it's just looked at as an energy generation source and they're going to pay, you know, the cheapest amount, all competitive based RFP responses. So I think that is a barrier. And I guess just to sum that up, that holistic approach, being able to take a bit of a higher level look and say, well, where do we put our wind? How do we value our wind? Even on a country context, the whole national context, it would be great to have stronger interties between the provinces and put wind where it actually makes a lot more sense. I mean, I see the one comment was 70% capacity factors at Pincher Creek. And wouldn't that be tremendous to be able to put additional wind resources there and have stronger interties across the provinces? So,
Ryan,
yeah, I was just going to say I kind of had a follow-on question for Tim, and in some of your proposed spaces that you're looking at where we haven't built wind in Alberta because the wind resource just isn't that phenomenal like it is in the south west there. What in your opinion is stopping that build out in a relatively open market? Is it because of a lack of overall systems planning approach? Is it because of the money? It's just not cost effective enough. Why aren't we doing this yet?
All sorts of reasons. First off, I should say I've never seen 70% capacity factors in Pincher Creek. But if we get there, I'd love to see it. Yeah, I mean, obviously the challenge in Alberta has been the open market. I think is without any sort of long-term PPAs, that price suppression has been a financing concern for everybody. I don't think that's a surprise. And it wasn't until the more recent contract for differences that people were able to kind of get around that a little bit. But now that I think the prices have come down to where they are, I think there are people that are starting to look elsewhere, and it's going to come down to, in my opinion anyway, sort of policy stability and around probably carbon offsets and those other types of things. The big trick right now, I think, is balancing the value of the carbon offset versus the market price, right? Like from a technical point of view, it would be nice to see a more diversified fleet, but if all I care about is actually, if I make more money off the offset than I do off the electricity, there's still sort of an advantage for clustering. And so that's generally why we're seeing most of the developments that are still happening in the south of the province.
Yeah, thanks.
I want to flag Eldridge and just picking up from where Ryan was, and I mean, it was Tim's perspective there was quite interesting as well. And I mean, there's a lot of focus on capacity factor in the utility world because they still want to build and operate the grid the way it has been done in the past, and we're trying to put square pegs in round holes. There's no doubt about that, and it's not going to fit. And I had an interesting conversation. I won't name the utility because I don't think it's worth the embarrassment potentially. But they were going through an IRP, and I mean, you'll get where I'm coming from with it when I say, because I was asking about offshore wind and why they didn't consider offshore wind. So it's one of 5 provinces, and I said, well, where did offshore wind factor into your planning? I said, well, we looked at it, but frankly, the capacity factors, the delta that we could get from our onshore resources wasn't worth the extra pennies that it was going to cost us. And I said, but capacity factor isn't the only thing. And they said, what are you talking about? I said, well, we've done some modeling of offshore wind profiles, and that's through Ryan Kilpatrick and his group at CanMet. And we demonstrated, just using some pretty basic analysis, that an offshore wind plant spends more time at the top of its power curve than an onshore counterpart very close by. That is less variable in that we measured delta from power output minutes to hours from one measurement to the other. And an offshore plant was simply demonstrated in a very simple way that it's less variable than an onshore plant, and therefore is more dispatchable if it spends more time at the top of its power curve, and is an easier asset from a grid perspective to operate if that's where the grid operator is. And so there was this notion that they're coming at this from a pretty simplistic way and not thinking about profiles, diurnal profiles, minute-to-minute changes, and so on, that I think is still not there in many parts of our grid operator world.
I completely agree there, Tom. And so if we turn attention to research and what we need to be studying, I think we got to get one more step ahead here, because there are a lot of interesting things we could research on the dynamics of the grid and integration. And I think there's a lot of work in the bag already, even in Canada. And so it's, and I'm shooting from the hip here. I don't have an organized, like, here, please, research community, do these things because we need it. It's more building on what I said in my introductory remarks on Monday, was we are past knowing what the machines can do. Like even Red, like your work there with loading and what SGRE is looking at on a daily basis, like it's pretty incredible, the amount of information. But we need to move to this systems approach in the research as well, and not keep hiving off into small sectors of the research if we're going to have a Canadian impact. I mean, there's plenty of stuff to do on the global scene for really specific targeted research. But if you want to have a big splash on the Canadian grid, the grid integration research really hinges around system performance. And that might be a behind the meter system of aggregation, like you guys are doing at Cowasis or at WeCan, how you've actually taken a system dynamic and shown that, demonstrated that. It gets to the data. Now you have proof. If frequency droops by this amount, I responded in this time frame, and here's my output. So that is great information to have. And then the system, it's incumbent on the system operator, who has the bigger set, to then feed that in. If we can get into the system operators to be researching alongside them and say, hey, you've got this park here, that storage there, this solar farm here, can you let us attempt a model? It's got to be locational specific. So these generalities of responding to frequency events, good, it's an input, but next level is drawing it all together to a location specific, because as we've, sorry, Eldritch, I'm going on a rant here. As we've attempted this within the industry discussion groups, we went from, okay, let's define the grid services. Let's at least put a definition to them. Came up with 6 pages of conflicting definitions from global spaces, that there's all this overlap between what fast frequency response is inertia fast frequency response now? All of these things are overlapping. So we said, okay, that's not helpful. What does Saskatchewan need? What does Nova Scotia need? Like, let's talk about the unique geography, the unique power mix that is already there, and attempt to help them answer their questions, not answer questions that nobody's asking. So, sorry, a little bit of a tirade there, but that's my piece.
There's one little bit of a tidbit I wanted to add, and that's the capacity question. The capacity factor question came up over at our site. Capacity factors of around 60 and 70 have happened. It sounds unbelievable that a wind farm is operating at 60 and 70% capacity factors, but it has happened, and it's largely due to the fact that we are close to the open ocean. So it's certainly possible.
Talk about making hay when the sun is shining, eh?
Exactly.
Wind is blowing.
Eldridge, Rob Brandon here. I'm on the board of WeCan. One thing that I've noticed is there's very little discussion about regulators. Now, I'm been out of the business for some time, but have the regulators, are they all still unengaged in this issue? What's the situation there?
I can attempt an answer, Rob. That's a great question, because ultimately they are the ones who make the rules for how all of this works, and we have seen things start to change. One of the places that I'm aware of that's changed recently is Nova Scotia. So Tom has mentioned this a couple of minutes back. They have gone through the process of updating their grid code, and I believe it changed sometime last year. I believe it was October or November. But there are changes in this direction to encourage more participation, a more fair participation for, say, a wind and solar on one side as opposed to gas and coal on the other. One of the places I've seen that this tends to get stuck, where this kind of becomes a chicken and egg problem, again, is exactly what Tom described, that something is there, something is available at the moment. So you don't need to put a price to it, but you take it away, suddenly you're left with the question of, okay, that thing that I don't have a price for, how much is it worth to me?
Yeah.
Anyone want to add to that?
Well, I'll add, Rob, some of your old colleagues from NRCan are trying to figure out how to crack this nut. I think regulators are aware of the challenges. Utilities, they play a very specific role. Utility comes to them for projects. They want to rate base it, in its most simplest and basic of forms, and they seek approval. They may go through an alternatives analysis, but they're really hamstrung by the regulatory framework itself. What is in, what is out, what is eligible to be rate based and what is not. And a lot of the things that we're talking about were not contemplated as part of, kind of traditional utility practice. And so they're stuck with the confines of the rules in which they operate. And I'm going to pull it up on my screen so I can make sure I get the right acronym. It's this Innovation and Electricity Regulation Initiative that Jen Hiscock, who I know Rob, is leading, and Michelle Maxwell as well at OERD is bringing all the regulators together, as well as a number of other stakeholders, to look at what they call innovation sandboxes, where a regulator might be able to test a new way of looking at a non-wires solution, for example, to provide some sort of benefit to the grid, whether that's reliability, resiliency, rate, impacts, reduced impacts on rates, and so on. And go through a process of examining that and seeing how it fits. Now, it's baby steps. It's moving in the direction that I think we're all aware that we're going in, where we're going to a much less carbon intense grid, that we're electrifying thermal loads that have traditionally been off that electric grid, and we're now moving them on. And we're looking for them to do different things for us, that they're not just electrifying to reduce carbon, but they're maybe electrifying to provide grid services, as it were. So I'd say that the regulatory industry is hit and miss whether they're aware of it. Some may be pushing against it, some may be embracing it. I do think Nova Scotia is leading in many regards. I think the chair of the UARB is quite bullish on this stuff, and I think wants to be, because I think they recognize they have a problem. They have a capacity crunch coming up, and they need to solve that. And they're not going to necessarily solve it by way of traditional utility design around, where am I going to get my capacity from? So there's a lot out there, and I think there was a bit of a reluctance by the federal government to engage with regulators because of the notion of, well, is this really a role for us? But certainly, I think through like Utility Forum and this IERI work is showing that we can at least play a convening role, that we can at least start helping to share lessons learned, bring other perspectives in, and see if we can move the needle on regulatory reform as well as market reform.
Thanks, Tom.
I have something in mind. I have a question actually. So is it possible somehow, or it is something that we maybe need to do, how much the regulatory and utility companies know the value of what we do, or how much they think that what we do is going to improve their gain, economical gain? Because maybe it is something that we need to show for them in order to be able, or in order to understand what we're doing is important. What is your thought on that?
I can take a shot at that one. I don't think they have the capacity to value what we do until the moment is there in front of them. And so until they're faced with it head on, they don't ask the question, and we've attempted, right? We've produced some documents and that kind of thing saying, hey, look, we can do more than energy, and we've laid out what we can do. We've got some work going on about getting into the specifics of inverter-based resources and what they can actually provide, what services equivalencies they can provide versus thermal plants. But I've found personally anyway, that they don't ask those questions. They don't ask about value until the moment is right, when they saw that solar plant offset the drop in the wind speed, right? Until they saw that, like, oh wait, that actually really helped me out. Hey, Canria, can you let me know, is this something that you see elsewhere, or there's any research on this? And so this is the frustrating part. And that's where, even to the previous question about the regulator, I think we're going to get there. I think we are. It's going to move. Even the economics are going to drive it forward. The price of energy is just from these resources is going down. But it's the pace at which we get there that could use a boost, that could use some research. So I think that's a great question, Rad. I think that it's a double spoke in that you have to be able to demonstrate the value, but you also have to be there at the right moment to interject it into the system.
Yeah, I'd say that the work that SRC is doing, Alberta Innovates, you know, that's really important work, and of course WECAN's work. It needs to get out there. CANRIA is a phenomenal mechanism, is able to get that word out there. I think, you know, the utilities and regulators are aware of this, and I think some of them struggle because, you know, they've got a lot of different considerations to make. I think we tend to come at it from a very much, well, it can do it, so why aren't you using it? Therefore, you know, you should be doing that. And but it's not necessarily that simple. And there are, you know, when the lights go out, it's none of us who get the phone call. It's the utilities. Or when the rates go through the roof, if it's not done right, it's not us who get the phone call. So you know, it is a challenge. It's I don't like even, you know, positioning it that it's a difficult problem and therefore it's going to take time, because you know, we're running out of that time, and we need to get to it. And I think we're seeing a lot of you know, a lot of different jurisdictions around the world and in Canada make these necessary baby step changes in some cases, some of them, you know, big changes. I'm encouraged. I've said it, Nova Scotia, their PPA work and their regulatory work, I think, is good. And so hopefully it's just a question of getting this out there so that it's not a sky is falling when I hit 50% inverters on my system, that I recognize that there's an opportunity there. And I'd also say the public still needs to be convinced that it's not just putting solar panels on your roof because it makes you feel good. There actually might be an economic value there. If there's a new market for you to participate in as a homeowner, people are getting into their own little, you know, areas of buying and selling stocks on their own on their phones. Why aren't we able to do the same with our solar panels that we put on our roofs? Buy and sell those to do different things at different times of the day, because there's different value for that.
Okay, just one thing to add here on a different note, keeping track of time. We have about 10 minutes before the close. So what I'd like to do is I'd like to throw the floor open to anyone else for questions. And we can probably spend another 3-4 minutes on questions if there are any. So anyone, now's your chance.
What are you doing next, Ryan?
Good question. Actually, right now we're looking at different value streams for the energy storage system. It's been a good success. We've kept it in good working order, but same as wind and what we're talking with the utility, we're trying to find ways to show the utility all the extra value that a battery can bring. We've had SAS Power out to site many times, and they always, I think we've had 6 or 7 different groups of SAS Power come out and tour the system. So we're trying to really engage them, and they're excited about the system. They see the value of it, but there is just no mechanism right now to value frequency response, time of day, you know, that whole thing. So that's one thing we're really trying to get on SAS Power, and we're looking at doing a larger energy storage demonstration with them. I'll put it as a feather in my hat. It probably isn't, but SAS Power is looking at procuring 20 megawatt hour of storage in Regina. So that's a great step forward, and I think we've been a part of that anyway. But yeah, I'd like to see more engagement from the utility, not only in the side of storage, but I mentioned the geospatial diversity in the province. It would be a great aspect to keep going on. And yeah.
Great, thank you. Yeah, thanks for all the work you do.
Anyone else with questions? I do have one final question then. Seeing as we have quite a few people from the academic and research communities here, the one question I will ask is, can you think of the kind of demonstrations, the kind of work that someone like WeCan should be doing? One of the things we like to focus on is doing field demonstrations and actually gathering data so we can put data out there. Does anyone have suggestions for the kind of work we should be looking to do? Could be wind, could be solar, could be storage.
Actually, it's not directly answering your question, but I was about to write something in the chat that at iSpeak we developed a game, and the name is Megawatts and Marble, and that game is simulating a grid operator and how with different resources based on the rules and regulation you are defining, you can have a game that people playing and showing them like, okay, so if you have wind, if you have coal, if you have gas, how can you operate and manage your grid? So this is not exactly your answer, but it is something that we have done and it's worth to have a look. I'm going to leave a link in the chat room. Please have a look.
Anyone else who'd like to chime in?
Rob, I just wonder whether, because of WeCan's position so close to a marine environment, I'm interested in the resurgence of offshore wind in Canada. Particularly, there was a lot of thought about offshore wind turbines in Lake Ontario, close to the GTA. Is that idea coming back? Is there some work that WeCan can do looking at some of the marine impacts on wind turbines that would be maybe a little easier to do at WeCan than in other locations?
I'd like to take a crack at that, Rob. So as far as Lake Ontario, moratorium is still there. I don't see any movement, nor would I expect to see any movement. The Atlantic region, there is certainly growing interest, I think. I've even started seeing interest out of the petroleum boards. Shrinking revenues in one sector is certainly, I think, causing their interest to peak a little bit. Is there you look at the lease area valuation out of the U.S. Northeast, and we're talking, hundreds and hundreds of millions of dollars just to have a lease area, carved out for any given company. Big players, Shell, BP, and so on. So I think that there's a lot of interest, but at the same time, there's challenges, be it grid challenges or otherwise. In terms of a role for WeCan, I brought up offshore wind to Scott several moons ago, and his tune has changed in recent times. I think he's recognizing there may be something there. Not that I'm speaking for Scott, obviously, but I think I wore him down a little bit, at least enough so that I could not get barked at when I brought it up. For those of you who know Scott, he's a man of well-informed opinions and is not afraid to share them. I've worked with him a long time, and I'm looking forward to continuing to. I think the one area that might be interesting is the foundations and the notion of floating. If you look at the Atlantic region, We don't have to get too far offshore before it gets very deep and much deeper than what traditional pile or traditional, I guess, monopole type of structures can be installed. And so I think the floating platform is interesting. I think that WeCan could play a role in helping either locate where such a floating platform could be, and WeCan could play a role in being part of an organizational approach to evaluating costs and opportunities of on the O&M side and on the facility side, how big of a wind turbine could it support and so on. I think it'd be an interesting research area, and I think floating is certainly the direction the industry is going in, and so that might be one area.
Thank you, Tom.
Okay, with that, I think we will end this breakout room here and return to the main one. It'll probably be a minute or so before everyone else returns, but I will see you back in the main room. Thanks everyone for your contributions. This has been a great little discussion here.
Thanks for the space.
So we're close to the end time here. I think I'll just I'll keep moving here and end on time. People can catch up as they join. So the just a quick reminder: we have two other webinars coming up. One on the fourth. Number 4 is on the 29th, and the fifth webinar is on the 31st. The fourth one is about asset management again, and the final one is cold climate and climate change topics. So any feedback, any more information you'd like, please feel free to reach out to either Marianne or I. And the one thing I will say in closing is please stay tuned for possible funding opportunities. We will likely do a follow-up webinar at the end, and we will be back with more information. So with that, it's almost 2 o'clock Eastern, 3 o'clock Atlantic. So thanks for your time, and have a good rest of your day.
Thank you, Aldrich.
Yeah,
Take
thank
care,
you.
everyone.
Is everybody back from their breakout?
Hey, Gary. So
Hey, how you doing?
good. Yeah. So Aldrich just wrapped up his section here.
Okay.
And basically all that you guys missed was this last slide. But I'm just going to pull up
Okay, perfect. Yeah.
the main here. And just all we're talking about is the
follow-up. Okay, I can run through that if you want, Jeremy.
Go ahead.
For this group. Yeah. Yeah. So looks like we missed getting Eldridge back, but what we're doing as a wrap up for this session is looking forward to next week. It's been a good first week. And so next week we're starting again with more asset management discussions, other components on March 29th. And then again on the 31st, going with cold climate and some climate change discussions. And if anybody has any feedback on how things have been going so far, please send them to Marianne. And we look forward to any opportunities that could come out of these discussions. And I thank everyone for contributing and for the great questions and the great discussions in our group. So thanks so much.
And thank
you. Have a great day.
Thank you, everyone. See you next week.
Thank you. Thanks for the chat.